In this video, we'll be looking at completing the square. Completing the square is the process where we rewrite a quadratic from its general form to a form where x only appears once. We'll start by looking at the steps for how to do this when a equals 1. Let's use an example to talk through the steps. We would halve the coefficient in front of x to get 3. We will then write x plus 3 squared, and then we'd also take away 3 squared. And the reason we take away the 3 squared is so that if we would simplify that expression, we would be left with x squared plus 6x. So all we need to do is just add the constant on at the end, so minus the 7, and then simplify to get our final answer. We could quickly check if we made any silly mistakes by substituting a number into the first expression and the last expression. So if we chose x equals 1, we would get 0 from both expressions. Now let's look at what we do in the case when a is not equal to 1. We first of all factorize out a from the two terms that have an x in them. So in this example, we would factorize out 3 from the first two terms. The reason why we don't factorize out 3 from all the terms is because it avoids awkward fractions. Now we just complete the square on the expression inside the bracket, so the x squared minus 8x. So half the 8 gives us 4. We still subtract 4 squared, even though there's a subtraction inside the bracket. We always take away that number squared, so we get minus 16. Then we multiply the whole thing by a, and then add the c. So multiply everything by 3, and then add the 5. Simplify the expression by multiplying out the 3, and then combining the constant term at the end. We can also use this method when the coefficient of x squared is negative. So we can factorize out negative 1. We can complete the square on the bit inside the bracket, so half the 14 to get 7, take away 7 squared, then multiply all that by negative 1, and then take away the 6, expand and simplify. It's better to start expressions with a positive term if possible, so we prefer to write this with the 43 at the front. However, you would still get full marks if you didn't do that in an exam. Now let's look at some uses of completing the square. One thing we can do is we can find maximum or minimum values of an expression. So let's say we have a quadratic, we can complete the square. And the trick here is that squared term is always greater than or equal to 0. Or if it had a negative in front, it would be less than or equal to 0. So in this case, x plus 1 squared is bigger than or equal to 0. If we add 4 to both sides, we get our quadratic is bigger than or equal to 4. Therefore, our original expression is greater than or equal to 4. So the minimum is just 4. Once we've completed the square, we can spot the minimum or maximum quickly. It will always be the value q, and if a is positive, it will be a minimum, and if a is negative, it will be a maximum. So this one here, it will be a minimum, and it will be negative 7. This one's got a negative in front, so it'll be a maximum, and it will be 5. Completing the square allows us to find the coordinates of the turning point of the quadratic graph. So if we have a quadratic graph, we complete the square, and straight away, we know that the minimum value of that expression is 4 from what we've just done. So all we need now is to find x coordinate. So the minimum happens when that square bracket is equal to 0. So therefore, x needs to equal negative 1. So x is just negative p, and the minimum or maximum y value is just q. So we can quickly write down minimums and maximums. So for this one, it will be 2, negative 7. And for this one, the x will be 4, y will be 5, so it's 4, 5. We can also use completing the square to rearrange formulae. For this formula, there are two terms that have x in them. This makes it hard to rearrange. Whereas we complete the square, there's only one term now that has an x in it, which makes it easier to rearrange. So rearrange it. When we get to the step where we have to square root both sides, remember to include the plus or minus sign. Sometimes in the question, there'll be additional information that allows you to ignore one of those signs, but if not, you have to include both of them. And then finally, finish it off to get x equals. This same method can be used to derive the quadratic formula. Have a go at this yourself. Let's have a go at a worked example. Pause it and try it for yourself first. In part A, we're asked to complete the square, and we can see that there's a coefficient in front of the x squared, so we follow the steps for when A is not equal to 1. So factorize out the 2 from the first two terms, complete the square on the bit inside the bracket, multiply by the 2, and then add the 21. So now we know straight away that A is 2 and P is -3, and we can just expand and simplify to get what Q is, which is just +3. For part B, we're asked to show that the expression is always positive. It says the word hence, so that means we have to use what we've done in part A. The key here is that the squared term is always bigger than or equal to 0. So we can build up our expression from the squared term, so multiply both sides by 2, add 3 to both sides, and we get that the quadratic is bigger than or equal to 3, and 3 is greater than 0, so we know that the whole quadratic must be bigger than 0, therefore it's positive. In summary, completing the square is the process of rewriting a quadratic from its general form to a form that only contains 1x. Completing the square is used for finding the maximum or minimum value of a quadratic expression, finding the coordinates of the turning point of a quadratic graph, and rearranging a formula which contains a quadratic expression.